Hi guys, welcome to my channel. Today let's solve the Leet code question. The description of the question is as follows: that there are n students in a class numbered from 0 to n minus 1. So I'll just write some note points. The number of students in the class are n and they are numbered from 0 to n minus 1. The teacher will give student to a the teacher will give each student a problem starting from index 0 and 1 and then so on until n minus 1. After, teacher will restart the process starting with student 0 given again. Okay, so each student requires chalk of I to solve a problem, and there are k pieces of chalk initially. So if the current number of chalk pieces is strictly less than chalk of I, the student number I will replace the chalk. Okay, got it. So for explaining more clearly, let's deep dive into the example that's provided. The chalk pieces that each student required is given as 5, 1, 5 in the first example, and k is given as 22. So initially there are 22 pieces of chalk, and out of which 5 pieces will be required by first student to solve a problem. 1 piece would be required to solve a problem by second student. 5 pieces would be required to solve a problem by third student. So first time or the first iteration, the first student will take 5 or consume 5 chalks out of these 22 pieces and will be left with 17 pieces of chalks. In the second iteration, the second guy will use 1 chalk and will be having 16 chalks left, and I'll also write how we got that 16, and this would be 22 minus 5. So in the third iteration, similarly, what would we get is 16 minus 5, that would be 11. So 16 minus 5, that would be 11. In the fourth iteration, again we would get 11 minus 5, that's 6. So that's 11 minus 5. In the fifth iteration, we'll get again 5, that's 6 minus 1. In the sixth iteration, we'll get again 0, that's because 5 minus 5, and there are no chalks left now. For the seventh iteration, i.e. seventh iteration is again the first student, right? i.e. 3n plus 1 multiples would be first student, because there are total number of 3 total number of students. 3n plus 2 would be second, 3n plus 3 would be third student. So here 7th student will be the first one to replace the chalk because he does not have any chalk piece left. So this is the case how this should work. And for having this problem done, what I am telling you is, I'll just in the first go, I'll just check how many iterations do all the students able to solve the problem or able to use the chalk pieces. So for having this done is fairly simple. I'll just accumulate the pieces that are required by all the students, and I'll simply divide my k value with this accumulated value. So if I divided the k value with the obtained value, then what would be having is the total number of times or the total number of times all the students would able to solve the problem without replacing the chalk. So that's how it works. In more example or in a more clear way, I'll just consider the first example 5 and 5, and the total of this would be 11. So for all the students to solve the problems in one iteration would be requiring 7 chalk pieces, 11 chalk pieces, and in total I am having 22 chalk pieces. So if I divided 22 upon 11, I'll get 2. So I am just specifying that for 2 iterations all the students would be able to solve the problem. That's fine, no, because that could be always seen, because first student or the total number of chalks required by all the students is 11 and we do have 22 chalks, so 2 iterations they would be able to solve the problem without any uh, dissatisfaction or replacing the chalk. In the second example, if I just consider 3 4 1 2 and total to be 25, 3 4 1 and 2 adds up to 10, so here it would be 25 upon 10, but we don't need a cap of it, we only need minimum value of it. So I'll just specify that in 2 iterations I would be able to solve the problems, and then I would be having 5 chalk pieces remaining for the third iteration. Got the point what I'm trying to say? For the third iteration, so I'll just specify that over 2 iterations I would be able to solve all the problems, or all the students would be able to solve the problem without replacing the chalk. But for the third iteration I'll be left only with 5 chalk pieces. In that case what I'll do is I'll just iterate from start to end again, and I'll just check if the current student required the chalk pieces that are present greater than the current student requirement. If it's greater, then I'll just subtract those number of chalk pieces from my current existing chalks and I'll proceed further. If in the case the student required 8 number of chalks but I'm having only 5 chalk pieces, in that case I'll just return that index. So that's how it works, and I'll just call it long sum equal to 0, because you could see that chalks can vary from 1 to 10 power 5 and also n vary from 1 to 10 power 5. So in order to find the accumulation, instead of using integer I'll just use long of it, and I'll just iterate through every element in the chalk. I'll just do what I told you, that will be equal to element into 1l, and after finding that I'll just call int number, I'll just call it. So for finding the number, what we discussed is sum upon k, and k now will become k equal to k minus, I already told you here, right, 5 would be remaining. So how I got that 5? That's k 25 minus this value is number, right? So 25 upon 10 into 10 again. So k equal to, what I am doing is k minus, that's the first one which I done, 25 upon 10 which is number, into what's my 10 over there, sum. So k would be equal to k minus number into sum. That's simple of it. And now I'll just also keep track of my size at the starting, chalk dot size. So I'll just iterate through my vector, and I already told you I'll just check if my chalk of I is less than, is greater than k. In that case I'll simply return I. If it's not the case, then I'll just do k minus equals to chalk of I. So simply I'll just return minus 1 if it's not the case, because I'm pretty sure that this won't ever come outside the loop. So that's working as expected. And in order to fairly reduce the complexity, fairly reduce the time taken, what I'll do is I'll just specify my C++ compiler not to include any libraries from C that will be helping me to take input or give output anything to the terminal. So cin.tie to be null, similarly cout.tie also to be null. I'll just try running this out. This should be double pointer, right? That's working fine. Let me just submit this out. Great, we bet 98%, 98.12% people with our complexity. Feel free to add anything in the comment section if you think anything is unclear. Thank you.